Hello, and welcome to part 3 of your Exam 1 review. We're going to start on question 20 that just says write an equation talking about the relationships and the problem. All right. So for problem 20, part B, it just says create an equation for these relationships. So part B, median home prices in the U.S. were about $186,000 at the end of 2008 and fell about 2.5% per year for a few years. Let M be the median household price and T be the number of years since 2008. So, since the price is falling by a percentage, that means we're going to be using an exponential function following kind of the formula y equals a times b to the t, where a is the initial price and b is the rate. So a is pretty easy. It's just $186,000 because that's the starting price. But b, our rate, since it's falling about 2.5% a year, that means we have to subtract 100% from 2.5% so that we get 175%. And then we can put it all in our formula. Our y is going to be our median household income because it's affected by t. Our starting value is $186,000. And then times our rate in a decimal form to the t. And that is our equation. Then, for part C, Dan has an annual salary of $30,000 when he was hired and has an annual salary increase of 3.2% each year since. Let D be Dan's annual salary and T be the number of years. Okay, so same thing as the last one. Since this is in a percentage, that means percentage increase each year. That means we're going to use the same formula as we used up top. Our starting salary is going to be $30,000 given in the problem, so that's going to be our A. And our rate is going to be 1 plus it's going to be 100. My eraser's so tiny. 100 plus 3.2, and that's going to be equal to 103.2%. And then we can put it in in our formula. So D is going to be for Dan's annual salary that is affected by time, and T the number of years. So A is our starting, which we said was 30,000, and then the rate in a decimal to the T years. And so that is going to be the equation for part C. So part D. A restaurant's once averaged about 500 customers each week. The restaurant has gained about 12 customers each week since changing ownership. Let the number of restaurant customers and let R be the number of restaurant customers and T be the number of years since the change in ownership. So for this problem, since we're dealing in number of customers, we know that this is going to be linear. So that means the equation we're going to be using is y equals mx plus b, where m is the slope and b is the y-intercept. So if b is the y-intercept, and we know that we started with about 500 customers each week, that's what b is going to be. And if we're gaining 12 customers each week, that is a rate, and so that means that is going to be our slope. So if R is the restaurant customers, that's affected by time, so that's going to be Y. So R is equal to 12 customers per week times time plus our starting number. and that is going to be our equation for part D. On to question 21. The population of India was about 1.22 billion people in 2013 and was growing at a rate of about 128% per year. Part A. Write a formula for the population of India in billions as a function of T years since 2013. So, since we're dealing with percentages again, we're going to be going back to our equation. Y is equal to A, B to the T, where A is the starting value and B is the rate. And so A, our starting value, we know that the population was 1.22 billion in 2013. So that means that is our starting value. So P is our Y value. So affected by time, 1.22, and then I'll just put billion here, so everyone knows. And then we need to come up with our B, which is our rate. So our B is going to be equal to 100 plus our growth rate, since the population is growing, which is 1.28%, which is equal to 101.28%. And so we're going to make that our B value in a decimal form, all to the T, to signify the number of years since 2013. All right. So, part B. If the growth rate stays constant, predict the population of India in 2023. So, 2023 is 10 years since 2013, so that means 2023 minus 2013 is equal to 10 years. So T is equal to 10. So that means we just plug that in to our equation. And then plug that into our calculator. And we should get, and then round to two decimal places, so we get 1.3854557, which rounds to 1.3, and then that rounds up 9 billion. And that will be our answer. All right, part C. What percentage did the population of India increase in the 2-year period between 2015 and 2013? So for this problem, we know that in 2013, the population was 1.22. And so what we need to find is what the population in 2015 was. So we go back to our formula and we plug in our B is equal to our equation with a T of 2, because it's 2 years later. So when we plug that in, we'll get an answer of 1.2514. We want to make sure that we have all of these decimals so that we get a very accurate percentage. So now we're going to use a percent of change formula, which is the new minus the old divided by the old. So here, the new is our 1.2514, and I'm going to use more decimals in my calculator, and subtracting that from 1.2 divided by 1.22 times 100% to give us that percentage, and that will get me 2.5763, or rounded to 2 decimals, 2.58%, like that. Question 22. The table shows the value for a linear function and an exponential function. which function is linear and which one is exponential. Explain why. So, firstly, I'm just going to graph both equations, or each type of equation, so we know what we're looking at. A linear equation will look like this. Its growth rate is constant, its slope is constant. It will move from one number to the next at the same rate. However, an exponential function will grow. So in between each x value, it's going to gain more y value. So that's what we're going to look for inside of these functions. So for f of x, when we go from 3 to 6, that difference is 1.92, and from here to here is 1.2, and from here to here is 0.75. So the change in between those two numbers is changing. That means that this one is probably exponential. But let's check the other one. So going from 3 to 6, we get 0.6, and from this one to this one, 0.6, and if I were to had to guess, this one would also be 0.6, and it is. So since the change in the first one is different and the change in the second one is the same, that means f of x is exponential and g of x is linear. And the reason is because the rate of change for f of x is different, and for g of x it's the same, and that's why they're exponential and linear respectively. Part B, find the possible formulas that represent functions f and g. Round values to 3 decimals and growth decay factors to 4 decimal points. Okay, so for f, we know f is going to be exponential, so that means it's going to have a formula of a to the bt. Unfortunately, we do not know what a is, because we don't have a starting value. We have 3 and 6 and 9. And we don't know what b is because we don't exactly have the rate given to us. So we're going to have to do a little bit of math to figure it out. But luckily we have points. And so that means whenever we plug in 3, so ab to the 3, we get 5.12. And whenever we have a to the 6th, we have 3.2. So what we can do is we can solve one of them for a. So if we divide both equations by b to the 6th, we get a is equal to 3.2 divided by b to the 6th, and we can plug this a in here. So 5 is equal to and here we have some divisions of b to the 6th, or b to the 3 divided by b to the 6th. So that means that will be equal to b to the 3 down here, because they'll subtract. And so with a little bit of some division and multiplication, we can multiply this with 3 and divide it by, we can get b to the 3rd is equal to 3.12 divided by 3.2 divided by 5.15, and then take the cube root of that. And we get that B is going to be equal to 0.5 or 0.8550, rounded to 4 decimal places. So we can plug that into our A equation here. So we can put that's equal to 3.2 times 0.8550 all to the 6th. And I can plug that into my calculator. And get that A is equal to 8.192. So our formula for f of x is equal to f of x being equal to 8.192 times 0.85550 to the x. Should be x. We can put a box around that one. For part B, I'll do that over here. For g of x, we know it's linear, so it's going to have a formula of mx plus b. We know that the equation for the slope is equal to the change in y over the change in x. Oops. Change of x. So we have 2 points. We can just pick any 2 points. I'll do 6 again. So 6 minus 3 is equal to 0.252 minus 0.5. And plug that into my calculator. And I get negative 0.2. And then grab our 3 again, and we can put that into our equation. So g of x is equal to negative 0.2 times x plus b. Now we have to find b, so we can plug in our 3 again. Get 3.05 is equal to negative 3 plus b, and we can solve for b. So that's going to be 0.35. 6 plus b, and then add. That should be 0.365 b. So g of x should be equal to negative 0.2 times x plus 3.65. All right, on to question 23. Find each of the following for the graph of f shown. So, f of a. So, we go to the graph here, we go to a, and we look up, and the y value associated with that is p. So, f of a is equal to p. Solve for f of x is equal to r. So, since it's equal to r, we know that's a y value. I'm going to go to my y value, and I'm going to see where that is. Oh, it touches the graph here. So go down. So it looks like it touches it at x equals b. But also, if we keep going, we can see it touches it again here. So if we go down, it touches it there. So we have to include d. Okay. Solve where f is equal to 0. So f of x is equal to 0. That means that the y value is equal to 0. So we go to our 0 here at the origin, and we go over, and it doesn't touch the graph. So that means that there's no solutions to that problem because it doesn't touch the graph. No solutions. Find the intervals on which f is increasing. Okay, so for this one, I'm going to start here and just go across the graph with my finger. So it's going down, going down, going down. We're going down. We're decreasing in value. I hit C. Oh, I'm not increasing at all. And now I am increasing. I'm increasing, I'm increasing, I'm increasing, I'm increasing. So that means that C is the starting point for where I am increasing. And everything past that is also increasing, so it's going to go to infinity. So that means that our interval is C to infinity. Is the average rate of change from x is equal to a to x is equal to b positive, negative, or 0? So b, a to b. So a, if we go up, is here, and b is here, and we're going to draw a line going between them. And if I look at this line, I can tell that it has a negative slope because as I go across the line from left to right, it's going downwards in y value. So that means it has a negative slope. So negative because the slope is negative of its secant line. Is f of d minus f of b all divided by d minus b, positive, negative, or 0? Explain. Well, if I look at this formula, I know that this is the formula for the slope of a line. This is y2 minus y1 over x2 minus x1. So I know that means it's looking for the slope between d and b. So if I come back to my graph, I go to b, beep, 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 here, and d, and I draw a line in between them, and since these y values are both at r, that means y2 minus y1 is equal to 0, and that means that the slope is going to be 0. 0 because they have the same y value. Alright, part G, find the slope of the line that passes through D and E. So I'm going to go to my graph. Here we're finding the slope, so that means we're going to, we're going to use our equation, the change in y over the change of x is equal to the slope. And so we know that our change in y is E minus D. So we need our y values for E and D. So I'm going to go to E, and I'm going to go up, and here's E. And I'm going to go, and I'm going to see it's at P. So y2 is going to be P, and then that's going to be minus y1, which we're going to go to D, and here's where it hits the graph. And we're going to go over to R. And I don't have values for that, so we're just going to box this answer, and that is going to be the right answer. All right. Number 24. If f is a decreasing function, which is the largest? So, if my function is decreasing in any way, shape, or form, that means, for instance, this is just a linear line. As I go to the left, the y values are going to be decreasing. So that means the more left I am, the higher my values are, and the more right I am, the lower my values are. So, for this problem, the value with the lowest x value should be the largest, in which this case it's A. Because that's going to be here, while all the other ones are going to be here and here and here and here. And that's going to be true for any decreasing function, because that's going to be here, 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 and so on and so forth. All right, so for question number 25, it says, for the function shown, on which interval is the average rate of change the smallest, and why? So, let's draw some points and see what those average rate of changes look like. So we have -1, which is about here, and 2, which is like that, and then we have 0 and 1, which is like this. We got -1 and 0, and then 1 and 2, which is going to look like that. Right, so it says which one is the smallest. So for these intervals, they're all negative. And with negative numbers, the smallest negative number is actually the largest value of that. So that means that the black line, which is the steepest slope, is actually the largest rate of change because it's the most negative. So that means that A is going to be the smallest because it's the most negative. For question 26, this is fill in the blank. If f of A is equal to f of B, the average rate of change of f on the interval A to B is what? So, we can do a little math with this one. We know that the average rate of change is the change of y over the change of x. And that means that f of A minus f of B is equal to A minus B. And if these are the same, that means we can substitute one in for the other over A minus B. And we can get that this, here, the top part, they're subtracting each other. So that means they're equal to 0. So that just means the whole thing is equal to 0. And that means the average rate of change is 0 because the y values are the same. Question 27. The graph shows a linear function labeled a, b, c, and d. Each can be written in the forms y equals mx plus b. Identify which of the four graphs has the indicated properties. Explain your reason for each. So, A, m is greater than 0, and b is less than 0. So, for all of these, they're talking about m and b. So I'm going to write out our equation. Y equals mx plus b. We know that m is the slope, and b is the y-intercept. So that means whenever x is 0, m and x are 0, so that leaves just b, and y is equal to b. So whenever x is 0, that's what the b number is going to be. And m is the slope. Whenever we change x, it's going to be changed by m. So m, whatever m is how much x changes by. So when we look at one of these graphs, for example A, we know that the slope, this one is negative because it goes down whenever we increase. And we know b is positive, so that's negative, and b is positive because it's above the y, or above the x-axis, on the y-axis. So using that information, we determine that a has a negative slope, b and a positive b. B here has a positive slope because it's increasing as it goes to the right, and a positive b, because it's above the x-axis. For C has a negative b with a positive m, and D has a negative slope and a negative b. So using that, A, slope greater than 0, B less than 0, so we can go below the x-axis and find that C is the one below the x-axis with a positive slope. So C. B, slope less than 0, so negative slope with a B greater than 0. So we go above the x-axis and we find whichever one has a negative slope, and that is A. And C, a slope greater or less than 0 and B less than 0. So once again, we're going to go below the x-axis and find the slope that is negative, and that's going to be D. So 28, consider the function has a domain of all real numbers. Sketch a possible graph of a function g with the following properties. The rates of change is negative from negative infinity to 3 and from 5 to infinity. The rate of change is positive from 3 to 5, and the graph is concave up from negative 4 or negative infinity to 4 and concave down from 4 to negative infinity. All right, so it's asking us to find a potential graph. So I'm going to draw a graph here, and we're just going to kind of label it. So it's saying at 3 here, we'll call this 3. It's a negative function, and also here at 5 it's negative. So this part's going to be negative, this is going to be positive, and this is going to be negative. And then it also says here at 4, on this side it's going to be concave up, so it's going to look like this, and concave down, which is going to look like this. So from this information, I can infer that if we have a point here, this is where the points are going to change. So this is going to look like this, and this is going to look like this. And we can check our points here. So this is about right, because here we have a slope of 0, and this side it's decreasing negatively, so that's negative, and here that's positive. And here we can kind of shift and go back a little bit, kind of fix it there. So now here at 5 it should have a slope of 0 ish. I'm not an artist, but here it's positive still, and then here it's going downwards again, so it's negative. All right, so that's what our general graph should look like. Then in part B, what is the value of the inflection point? What is the x value for the inflection point of this graph? So the inflection point is where it switches from concave up to concave down, kind of given by the last bullet point, but for B, that's just where x is equal to 4, because that's where the attributes of the graph change, right there from the concavity.